Germany has found the key to endless energy with its new nuclear fusion reactor. By breaking a record with its new nuclear fusion reactor, Germany's top plasma research center has shown that we are getting closer to the magnificent goal of fusion power, an essentially limitless source of pure, renewable energy. German scientists have developed an innovative new nuclear fusion reactor that could transform the way that energy is produced. It seems that Germany's new nuclear fusion reactor will affect the future of renewable energy sources. So stay tuned till the end to learn more about what Germany has planned and how the country plans to change the face of nuclear energy. Do you know that scientists in Germany's Max Planck Institute for Plasma Physics have constructed a nuclear fusion reactor with the ability to produce energy in a matter similar to that of the sun? If not, you might be surprised to learn just how massive this reactor is. Measuring 5 meters in height and 15 meters in diameter, it has the capacity to produce extremely powerful nuclear energy. If this technology advances further, it may even mark a turning point in the history of science and technology. The idea behind fusion power is to use the heat produced by nuclear fusion reactions to create electricity. When two lighter atomic nuclei fuse together to form a heavier nucleus, energy is released in the process. Fusion reactors are machines made to absorb this energy. It sounds amazing, right? But have you ever wondered how it is possible to make such a spectacular amount of nuclear energy? In order to manufacture or recreate the energy of the sun, we must first understand more about its nuclear reactions. We must first determine whether it is the fusion reaction or another type of reaction that produces the sun's energy. With the help of such technology, we can also become an interstellar space traveling civilization. German physicists recently powered up one of the largest nuclear fusion devices for the first time, and it was successful in holding onto very hot blobs of helium gas, also known as plasma. We are moving towards achieving a better sustainable living for our civilization. So the name of this reactor, Wendelstein 7X, is a stellarator, a type of nuclear fusion device that measures 16 meters in width. Although stellarators have been discussed for years as having immense potential, this is the first time a team has demonstrated that they can produce and regulate plasma just as well as other fusion reactor designs. Scientists are excited about nuclear fusion because it has the potential to provide a virtually limitless supply of energy from nothing more than salt water. Nuclear fusion occurs when atoms fuse together at extremely high temperatures and produce energy. It is predicted that this process will continue for a further 4 billion years after it has powered our sun for the previous 4.5 billion years. Nuclear fusion, unlike nuclear fission, which drives today's nuclear power plants, produces no radioactive waste and is far safer. It has, however, been extremely difficult for scientists to do, since it needs them to build a system capable of producing and controlling a 100 million degrees Celsius blob of plasma. Superconducting magnets are essential for regulating plasma, and scientists have already built 3 operational donut-shaped fusion reactors known as tokamak. Tokamak reactors, on the other hand, can only maintain plasma for a maximum of 6 minutes and 30 seconds at a time, which is insufficient time to harvest considerable energy. In other words, we've already achieved nuclear fusion, but it used far more energy than it produced. The Wendelstein 7X, an experimental reactor that is not intended to generate power, is getting closer to its fusion optimization targets. Along with stellarator experiments in the United States and Japan, the work is regenerating this unique and difficult fusion reactor design. And because of research at MIT and Google that uses new helium-3 fuels and electrical resistance plasma confinement, the world is getting closer to the promise made half a century ago of almost limitless energy created by the same technique that powers the sun. Though this experimental reactor will not produce electricity, it is used to evaluate the main components of a future fusion power plant. It was developed based on the predecessor Wendelstein 7 as an experimental reactor after 2 successful operation phases, ending in October 2018. The reactor was taken offline for upgrades. It resumed operations in autumn 2022, gradually increasing power and working towards the goal of producing electricity. This is not less than a holy grail, because if effectively explored, this fusion reactor has enough energy to power the stars, and it can deliver nearly infinite energy with zero carbon emissions. This fusion reactor has many advantages, and it is in many ways better than nuclear fission. But you may be wondering how it is possible to survive such an immense amount of heat, since no materials exist that can withstand such heat. Scientists have therefore developed a method for achieving fusion in a laboratory setting in which a superheated gas or plasma is kept inside a donut-shaped magnetic field. Scientists create this hydrogen plasma in a device known as a Wendelstein 7X stellarator, where hydrogen atoms are broken and microwaved until the temperature reaches 100 million degrees. It is 7 times hotter than the sun's core, so you can see how powerful this can be, among other things. Do you know where else the same amount of energy is produced? This entire process is similar to what happens at the sun. The structure of this Wendelstein 7X is pretty peculiar. A stellarator is a device that employs a sophisticated 3-dimensional system of coils and loops to control the flow of heated plasma through the gadget's loops, keeping it stable. This large-scale optimized stellar generator resembles a donut and is one of the most complex engineering models ever devised. It turns out that this shape was inspired by the first stellarator, which was invented by astrophysicist Lyman Spitzer at Princeton University in 1951 by bending the tube into a figure-8 shape. However, the lab he established in New Jersey, the Princeton Plasma Physics Laboratory, PPPL, switched to a simpler method for later stellarators, winding more coils of wire around a conventional torus tube like stripes on a candy cane to create a twisting magnetic field inside as it appears. This nuclear fusion reactor is more like a tiny star, despite scientists' efforts to make it simpler than before. These fusion reactors are still very difficult to build and even more likely to increase in the cost and delays than previous fusion projects. The leader of the German effort, Thomas Klinger, claims that no one expected what it would take to create one, which is understandable considering its unusual structure. David Gates, head of stellarator physics at Princeton Plasma Physics Laboratory, Gates says that the world's waiting to see if we get the confinement time and then hold it for a long pulse. The key measure is energy confinement time, the rate at which the plasma loses energy to the environment. This certainly is a major breakthrough in the field of science and technology. Such advanced technology was only a part of imagination and was out of reach. But today, as we see this happening and turning into reality, we can see how billions of dollars continue to flow into the field. It is one of the first new breed supercomputer design stellarators to have had most of their funding invested in it. Nuclear fusion has potential beyond what you can imagine. It can offer practically infinite energy with zero carbon emissions if it can be recreated on Earth. Science is now so close to the great objective of fusion power. Scientists have stepped closer to this reality. Imagine all that can be done if such powerful fusion energy can be utilized. This nuclear fusion energy is a promising long-term option for sustainable global energy supply. The world is desperately in need of such instruments that can harness such powerful fusion energy. The success of W7X gives the researchers hope that the next generation of fusion reactors will be able to reach that limit. Do you think we'll ever establish a sustainable way of life for all living things on Earth? Let us know in the comment section. If you like this video, hit the thumbs up button and subscribe to this channel. Thanks for watching.